All right, I think I'm live now. Can someone confirm if they can hear me and if my video is also perfectly fine? I still can't see any comment. Is there some lag or what? Nirmal says hey, Jeevan says hey, Vikas says hi. Today's contest is a little bit difficult and I'm a newbie. Yes, I can agree with that. Actually, like today's contest was a little bit difficult. Okay, even I didn't know like it will be so much algebra centric. Okay. All right, today newbie able to solve only one. That's perfectly fine. If you're starting up, even if you're able to solve the very first problem, that's perfectly fine. Even I remember in my very first contest of Code Forces, I gave it in second year, I think. I was able to solve only, I actually solved the very first problem and then it got hacked. So I was able to solve zero problems. So it's perfectly fine if you're able to solve one problem. Today's contest was hard. Hi, sir. Which iPad are you using? I'm actually using an iPad Air. Newbie in CF able to solve two. That's really nice. If you're able to solve two and are a newbie, then it's really good. Is the equation of DP? Yes, it's of DP. All right. Should I wait for a minute or two for more people to join, or can we start? Also, is my audio better? In day before yesterday's stream, I actually many people told me that there was some buzzing sound. Even I checked, there was some buzzing sound. I think I have resolved that. Okay, Vikas says, sir, Insta request accept nahi kari. Okay, I'll see to it. We have 14 viewers as of now. Yes, audio is better. Nice. Do tell your friends as well. I don't see many people joining these streams because I actually like went away for a long time from YouTube. So I don't think many people know that I've started streaming again. Shubham says, sir, are you observed today's problem more on maths or number theory? Yes, they were. Sir, ICPC के लिए register कब करना होगा? I don't really know about that. Just go to the ICPC website and check. I don't really know about ICPC now. All right, so should we start? Okay, I'll wait for a minute more. In the meanwhile, if there is any problem, anything you want to ask, you can just ask me. Today was another unsuccessful attempt of breaking Div-2 barrier. Okay. What do you mean by Div-2 barrier? I don't know. Is he a DP problem? Yes, it's a DP problem. Dipankar says good evening. Good evening, Dipankar. It's actually night, we can say. All right, quickly, can people tell me like how many problems they were able to solve today? I hope the first problem was okay. Even first problem was a little difficult, I think, because 10,000 submissions only as of now, or maybe it's because of system testing. No, only 10,000 submissions. That means less people gave the contest, maybe. Vikas says two, Swastik says two, Bhanu says two, Deepu says two. Okay, that's nice. If everybody was able to solve two problems, that is really nice. A third problem is a bit difficult. It's a DP problem. Even I took so much time in solving that problem. Should we practice questions based on topic wise or rating wise? That actually depends. Okay, if there is any specific topic that you know is something that you actually get stuck on, then you should what try practice what topic wise. Okay, otherwise you can actually go for rating wise as well. Like I have practiced both ways and both have helped me. So were you qualified for ICPC regionals? No, I wasn't. How to deal DP on large constraint? That's actually a very subjective question, I would say. I can't really answer that in one line. 23 registrations only. 23K registrations are very high, but only like 10,000 submissions for the very first problem. So I don't know, maybe less people participated, or maybe less people were able to solve the very first problem. Though the problem was easy, so shouldn't be that not many people were able to solve. Okay, I think we should not waste any time, and we should start with the equations. I'll be solving the first three problems only. Problem D, maybe I can try it on stream only. I am very close to the solution. I don't know the exact solution. I tried to open up solutions of other people, but I couldn't. Maybe there is some issue with code forces or something. So I'll be solving problem A, B, and C. So let's start. The very first problem is exponential equation. You're given an integer n. Find any pair of integers x, y such that x to the power y times y plus y to the power x times x equals to n. Now, the first line okay, this is the input and the output. So basically, we are given a number n and an equation. Okay, we need to satisfy this equation and give any pair of x and y. So, what is the equation? The equation is actually x to the power y times y plus y to the power x times x is equals to n. Now, I'm sure there are many solutions to this problem, but since it's a very first problem, you could actually try to hard code some values. Okay, what if we actually say that x is always equals to 1? If x is always equals to 1, then it becomes 1 to the power y times y plus y to the power 1 times 1 is equals to n. And if you see, this is nothing but twice of y is equals to n, which means y is nothing but n minus 2, n by 2. Which means if you set x equals to 1, then your y will be n by 2. And that's the answer. That's all you have to do. You just see that x is equals to 1 and your y will be n by 2. Now, since y is equals to n by 2, we need to see that n is even. Because if it's even, then only we will be able to divide it by 2. Okay, so that's all you have to do. If n is even, then an answer exists. Otherwise, the answer is minus 1. And the answer is 1 and n by 2. I'll quickly show my code as well. So this is the code that I wrote. I scanned n, then I just checked if n is even. If n is even, then the answer is 1 comma n by 2. Otherwise, the answer is minus 1. And that's it. Okay. I hope everybody is clear with this. And I'm pretty sure like everybody was able to solve this problem. If no, that's perfectly fine. It takes a little practice. But yeah, you should be able to do the very first problem after 1 or 2 contests. Okay. All right. So let's move to second problem. Pragnesh says clear. Perfect. All right. I don't see many likes to the stream. Only 8 likes. Do like the stream, guys. Now, the next problem says number factorization. Given an integer n, consider all pairs of integers array a and p of the same length such that n is equals to pi of ai to the power pi. And yeah, this is something I'll explain this like what it is trying to say. So basically, all right, let me open up notes. Okay, so what are they trying to say? If you see in the problem statement, it is given, we need to find, okay, let me take a screenshot of this only. Okay, so what are they trying to say? By this equation, they are actually like, what is the symbol for? This symbol actually means product of every value. So basically, you need to find the product of every value of ai to the power pi. Okay, so basically, you're given an integer n where you need to first find all the factors of n, okay, such that it becomes of the form a1, p1, a2, p2. For example, let's take a random number. Let's say we had 20. What is 20? 20 is nothing but 4 into 5, which means 2 to the power 2 and 5 to the power 1. Here a1 is 2, a2 is 5, p1 is 2, p2 is 1. That is what they're trying to say. Okay, where ai is the product of some distinct prime numbers. Now, it is not necessary that ai is a prime number. It could be a product of multiple distinct prime numbers. Okay. Now, let me just read the example and then I'll explain the problem once again. Okay. So, for example, for n equals to 28, n equals to 28 can be written as 2 to the power 2, 7 to the power 1, or 4 to the power 1, 7 to the power 1. Okay. If you take 2 to the power 2, 7 to the power 1, It actually means your array A is 2 and 7 and array P is 2 and 1. Basically 2 to the power 2 and 7 to the power 1. Okay, is correct. But the pair of arrays 4, 7 and 1, 1 is not. Why? Because 4 actually is not a prime number and it is also not a product of distinct prime numbers. It is actually a product of 2 times 2, which, and both 2's are like not distinct. You could only take 1 2. That's why this is not a valid array. Okay, so you need to make such valid arrays. Now your task is to find the maximum value of summation of AIPI. Okay, so basically first you need to find, okay, first you need to find for a given n, you need to find a1 p1 time, where a1 like n is actually a1 p1 times a2 p2 times a3 p3 and so on. Okay, now you need to find the value of a1 times p1. Okay, a1 times p1 plus a2 times p2 and so on till a of whatever. Okay, you need to maximize this value, and that's it. That's all you have to do. Let's take an example. Okay, so if you see we had this 100. What is 100? If you see 100 is nothing but 2 into 2 into 5 into 5, which is nothing but 2 to the power 2, 5 to the power 2, which means one possible array could be 2, 5 for A, and for P we have 2 and 2. This is one possible array. The other possible array could be, now you could also take product of distinct prime numbers. So what if we multiplied 2 and 5? This actually becomes 10 square, which means one other possible combination would be 10, 2. Okay, now if you try to find the summation of AIPI for this value, it becomes, what is your A1? Your A1 is 2. What is your P1? Your P1 is 2. So 2 times 2 plus, what is your A2? Your A2 is 5 and your P2 is 2 plus 5 times 2. This is nothing but 14. But if you look at this will actually give you 10 times 2. So 10 times 2, which is 20. And as you can see, 20 is actually larger than 14. Therefore, the answer for this is 20. Okay, I hope the problem is perfectly clear to everyone now. Okay, now how do we solve this? Okay, let me just go to notes again. All right, so what did we actually have? We need to first decompose in such a form that it actually becomes a1 to the power p1 times a2 to the power p2 times so on. Now you need to find the summation of a1 times p1 plus a2 times p2 and so on. And you need to maximize this. Okay, now how do we actually maximize this? Before that, let's first observe one thing. Okay, so let's say you had a prime number. Okay, since they've already taken p1, let's take x1. Let's say x1 is a prime number. Okay, now let's say x1 had a power of 2. Now one way is you can actually write this as what? X1 is one array, A array, and x2 is 2 is P array. So this becomes x1 times 2. When you actually try to find the summation, this becomes x1 times 2. So which is nothing but 2x. Okay, but you could also write this as x times x, which actually means x comma x. This is one array and the other array is this. Now if you try to find the this value, summation value, this actually turns out to be x times 1 plus x times 1, which is nothing but 2x. By this, what do we actually understand? It doesn't matter how many times a single prime number occurs. Okay, we can actually decompose them as individual values and then find the summation. We will still get the same answer. Okay, so let's say we had some value n. Okay, we had some value n, and when we actually tried to find the factorization of this, it came out to be x to the power a, y to the power b, z to the power c. Now, how do we actually decompose these values into these arrays such that the summation of summation of ai pi is maximum? Okay, so what do we have? This is nothing but xxx till a times. Then we have y, sorry, capital y till what? B times. And then we have z till how many times? C times. Okay. One such example for this, like one such decomposition could be that we can actually make how many arrays? X, Y, Z. This is one array A. Okay. In which this is A times, this is B times, this is C times. And then we have 1. Again 1, again 1. This is what? A times, this is B times, this is C times. And now if you see, when you try to find the summation of this part, it actually comes out to be x times 1 plus x times 1, so on till a times, plus y times 1 plus y times 1, so on till b times, and similarly z times 1 plus z times 1, so on till c times. What is the summation of this? Summation of this comes out to be ax plus by plus cz. Okay. Now, if you actually see, you had 1x, 1y, 1z, and they all contributed to 1x, 1y, 1z into the solution. But what if you multiplied this value? Because if you see, these values actually came out to be x plus y plus z. But we all know that x times y times z is actually bigger than x plus y plus z. So what if we actually, let's say we had x, then we had y, some y's, and then we had some z. What if we clubbed this x with this y with this z? Okay, so this becomes x, y, z. Then do the same thing for the other values as well. Let's say everybody was like 3 times only. Then we again have x, y, z. We have x, y, z. Okay, this is one array and the other array is 1, and 1. This is still the same thing. But the answer for this, the summation value for this actually becomes x, y, z times 1 plus x, y, z times 1 plus x, y, z times 1, which is thrice of x, y, z, which is obviously bigger than this value, because here we have product of all the x's and y's. Okay, so this is exactly what we have to do. Okay, let's say we had x some number of times. Okay, then we had y some number of times, and then we had z some number of times. What you have to do is, this is nothing but when you actually found the prime factorization of n. What you have to do is take a pointer for this x. Okay, take a pointer for this y and take a pointer for this z. Multiply all these three values, so you get x, y, z. Add this into your answer and then increment your pointer. Now again take the next value, multiply these values and then add them to the answer and keep on going. Now a condition will come when this pointer will reach out of bounds or the number of z's will be actually null. Then you only take pairs of x and y. Similarly, a time will come when x will also vanish. You only have y now. Then only take y's. Okay, so basically take all the distinct prime values that you have for now in one pass, remove those x's and y's. Okay, then take the next values. Okay, that's we have to do. Okay, I'll give you one example. Let's say we had x what? Thrice, y twice, and z once. What you have to do is you say x, you have y, and z. What is the answer for this? Okay, so basically what you had was you had an n, and this was x times 3, y times 2, z times 1. This x, this y, and this z, all these three are actually prime values. Okay, so What do you have to do? You will take this x, this y, and this z. You will say this is nothing but x, y, z. This is one value. Okay. What is the next value you take? You take this is added to the answer. Okay, because you will actually make an array of x, y, z. This is array A, and your array P will actually say 1. That x, y, z times 1. Now the next value is this x, this y. There is no z, so don't take any z. So now you say x, y, again 1. That x, y times 1. So you add x, y to the answer. Now y's are also finished. You only have one x, so you write x here and 1 here, and you add x here. This is your array A, this is your array P, and this is your final answer. That is all you have to do. Okay, I hope this is clear to everyone. All right, let me look at the comments. Okay, how was your journey in competitive programming? That's a pretty lengthy answer to it, so I'll answer this in the end. I think this we find prime factors in square root concept. Yeah, you actually have to use sieve of resources to find the number of all the prime factors and then find the answer. सर कोडिंग बिल्कुल नहीं आती, बस आपको बात करते हुए देखने आता हूँ. Okay, Ishan. Akash says after a long time. Okay, cool. All right. So I hope the logic is clear to everyone. If yes, we can go to the coding part. Okay, like how do we actually implement all this? Okay, let me see a yes or no if the logic is clear to everyone. This is for all those people who are not able to solve this problem. Or even if you're able to solve, maybe this is a better approach than you did. Okay. So let me just see if everybody is able to understand the problem. If yes, I can move on to the implementation of this. All right. Sai says yes. Okay, cool. Let's move to the implementation now. Nirmal says that's the same approach. Really nice, Nirmal. Nirmal says yes. Okay, perfectly fine. Let me just open up the code. All right. So what did I do? We had one n. Okay. The very first thing that I did was after scanning n, I found out the prime factorization of this n. Okay. So let's go to this function. This is nothing but known as sieve of irostresses. This is one, what do we say? Conversion of sieve of irostresses to find all the prime factors of a value n. Okay, you can actually like save this code for later as well. In CP context, you can't really write all these functions again and again. You can actually save this somewhere so that whenever you need this very thing in a context, you can just copy paste this function. Okay, that is exactly what I did. What this function does for me is it takes a value n and it returns me all the prime factors of that value with their occurrences. So if I had like 100, this will return me 2255 in an array, in a vector. Okay, so I stored all those values in this factor array, sorted them. I don't really have to sort this, I just sorted it. Otherwise, this actually gives me in a sorted manner only. Okay, now after that, what do I have to do? What I'm actually doing is, let's take an example for this. Okay, let's take a good example. So let's take what? 120. Let's take 120. So what is 120? Let me just do a prime factorization of this. So we have 2, 2, 2, 3, and 5. This is the prime factorization of this. Okay. Is this right? Yeah, this is right. Okay. Now, what I'm actually doing is I'm making a map, and then in the map, I'm actually writing the first occurrence of every prime factor. So this is index 0, this is index 1, 2, 3, 4. So what I'm doing is in the map, I see if I'm able to find the next value in it. Right now, my map is empty. Let's say this is my map. Okay, right now my map is empty. So since it is empty, I reach m.in and I say that okay, insert the value 2 for index 0. Similarly, move the iterator forward. Again, I have to now search this 2 in the map. Search this 2 in the map. I will say when I search this 2 in the map, I actually get an entry. Since I got an entry, I skip this part. And similarly, I move forward again the same thing. Now I come on to 3. When I come on to 3, I will see that okay, search this 3 in the map. Since this 3 was not found in the map, I will say that okay, I need to add an entry for 3. So 3, and then what is the index of 3? 3. Similarly, same thing for 5. For 5, we actually add 4. Okay, now this is the map. Now what do? I actually iterate. So why did I really have this map? This map is nothing but a pointer for every prime factor that I have. So basically, if you see, what do I have? I have one index stored for this 2, one index stored for this 3, and one index stored for this 5. Okay, what do I have to do now? Now, for while my map exists, while there are some values in the map, what do I do? These are some generic values, I'll tell later. I iterate my entire map and then say if it dot second, what is it dot second? Okay, right now I'm at the very first value, it dot second is 0. If this 0 is equal to factors dot size, okay, okay, if this is not equal to factors dot size, since it is not equal to factors dot size, we actually move forward, and it is also not equal to it dot first. Okay, so I say else current times it dot first. Right now my current is 1. So my current is 1 right now. I need to multiply it by it dot first, which is 2. Similarly, when I move forward into the map, when I go into this for loop, I will again get a 3, again get a 4. Sorry, 5. Okay. Now, and while every time when I'm taking one occurrence of that, I'm actually incrementing their indexes. M of it first. So now my index, this 0 becomes 1, this 3 becomes 4, and this 4 becomes 5. Now, next time when I actually come, now after this, I just go for iterating my to remove. Right now, my to remove is nothing. To remove is nothing but a vector for all the values that I have to remove from the map. Right now, I don't really have to remove any values from the map. Okay. After that, I just add this to my answer. So my answer right now has two. So my answer right now has 2 times 3 times 5. Okay. Now, again, I come onto this while loop. Okay, again I say to remove dot map, it is already clear only. Okay, now I say for the very first value 2, I say is 1 equal to factor dot size? No, it is not equal. Or is factors of it dot second? So factors of 1. What is factors of 1? Factors of 1 is 2. Is this equal to not equal to 2? No, it is actually equal to 2. So we skip this if and we go on to this else. In the else we say, okay, current again is also 1. Okay, we multiply this current by 2. Okay, then we increment the index. We again increment this index from 1 to 2. Now again we move forward, we come on to this 3. For this 3, we say, is this 3 equal to factor dot size? No, factor dot size is 5, so it is not equal. But is it equal to factor of it dot second? Factor of it dot second. What is factor of it dot second? It dot second is 4. Factor of it dot second is 5. This is not equal to it dot first. It dot first is 3. Since it is not equal, I will say push this value into remove. That I need to remove this 3 from the map. All the occurrences of 3 are already used. So I don't really need this 3 in the map. Similarly, the same thing will happen for 5. I will actually say that 5 is not required anymore since all its occurrences are used. Okay. Then I come out of this for loop. I remove all these values from the map. So I removed 3, I removed 5. Then I saw my current is not equal to 1, so add 2 to the answer. Similarly, if you follow the same step, again, I will increment my iterator. This 2 will come here and I'll add this 2 to the answer. And this will be my final answer. Okay, I hope this is clear to everyone. Again, I think like I have a feeling that my implementation is not the best implementation. There might be many easier versions of this implementation. Okay, so is this clear to everyone? Let me read the chart. The time limit exceeded is also an unsuccessful hack. Yes, it's an unsuccessful. No, it's a successful hack. If you are able to like go for time limit exceeded for any solution of any person, then it's a successful hack. All you need to do is that ensure that their verdict doesn't come out to be accepted. If it is not accepted, if it is anything other than accepted, it's a successful hack. But make sure that your input is right. Okay, prime factorization B level problem is too much. I think the problem set was pretty mathy today. What's your opinion about problem B? Yeah, I can agree with that. It's not really a B problem. It could be like a C problem. But yeah, it's a Div-1 plus Div-2 round, so it's usually harder than the other contests. So it makes sense. All right, so is this clear to everyone? If yes, we can move forward to the problem C, which is I think something most people came to see. Wouldn't it be easier to store every prime factor and its count and then start filling the answer array based on how much count each factor has? Yes, you could do that. Sai, Sai says yes. Okay. Yeah, again, I feel like I actually complicated the implementation a little. Maybe you can actually find some easier implementation of somebody else. We can actually go and look at Tourist's code if you want. I'm pretty sure like he would have used a easier implementation. Let me just see. So let me just see for second question. Oh, it is not opening the submissions. I don't know why we are not able to see the submissions. Okay, anyways, I think we can move forward to problem C now, which is remove the bracket. Now, I'll try my best to explain this problem clearly to you because it's a pretty complicated problem, I would say. Like, there are many constraints in the problem which you need to take care of. Okay, so n is less than equal to 1 to the power 9. How can we use sieve? We can actually use sieve. In sieve, the complexity of sieve is actually root of n. All right. So let's move to problem C, which is remove the bracket. All right. So RCJ has a sequence A of n integers, a1 till an, and an integer s. For each of a2 till a of n minus 1, he chose a pair of non-negative integers xy such that xi plus yi is equals to ai and xi minus s times yi minus s is greater than equals to 0. So let me just explain like what they're trying to say. So they have a sequence, okay, they have a sequence a1, a2, so on till a of n. What they did was they took this part, which is a2, a3, so on till a of n minus 1. Now for every value in this sequence, they found one x and one y, such that x plus y is equals to a. Okay, and xi minus s times yi minus s is also greater than 0. Okay, so these are some of the conditions. Now he is interested in the value of this. Okay, please help him find the minimum possible value if he can get by choosing x and y optimally. It can be shown that there is always at least one valid way to choose them. Okay, so let me explain the problem clearly to everyone. Okay, all right. So what does the problem really say? We had an array. The array was of length n, which was a1, a2, a3, so on till a of n minus 1 and an. Now they took all the values from a2 till a of n minus 1. And for every ai, they found one xi and one yi, such that xi plus yi is equals to a of I. Also, they had a value s such that xi minus s times yi minus s is greater than equals to 0. Okay. Now, we need to find some value f which is a1 times what? It is a1 times x2, a1 times x2, y2 times x3, y3 times x4, so on till what? It is y actually. Y of n minus 1 times a of n. This is the series. We need to find the minimum value of this. Now, before trying to find the minimum value of it, let's look at the constraints. The very first constraint is that xi minus s, yi minus s should be greater than 0. So let's write it here. So we have xi minus s. Okay, this should be yi minus s should be greater than equal to 0. Now, if you see, these are two different components. And in order for both these components to be greater than equals to 0, either both have to be positive or both have to be negative. Now let's look at how do we ensure that both these values are positive. In order for this value to be positive, xi has to be greater than n. So xi should be have to be greater than equal to s, and yi also has to be greater than equal to s. Similarly, for both the values to be negative, xi has to be less than s and yi has to be less than s. Then only we will be able to say that both these values, like the product of these two values, is greater than equals to 0. Okay, this is the very first thing. The next condition is xi plus yi equals to ai. So we have xi plus yi is equals to a of I. Okay, now let's look at the first condition. If we try to make the first condition, we know that, just a second, yeah, we know that xi is actually greater than s, yi is greater than s, which means this is greater than s, this is also greater than s. This means ai is actually greater than twice of s. Okay, and this condition is when ai is actually less than equals to twice of s. Okay, now how do we, let's look at this sequence now. Okay, when you actually look at this sequence, what do we have? Let me just write this again. Why am I not trying to? Okay, okay, so we had the sequence. Okay, now what do we have in the sequence? A2 actually has x2, y2. A3 has x3, y3. Okay, basically A3 is summation of x3 and y3. Okay, now A4 is the summation of x4, y4, and so on. Okay, now if you see, these are summations. Okay, but if you see here, we have to find the product, and we are also given that we need to minimize the product. Okay, so let's say if A3 is, let's say, 6, or let's take a smaller value. Let's say sum A is 4. What are all the possible values of x and y? We could actually have x0, y4, or we could have x1, y3, or 2, 2, or 3, 1, or 4, 0. Okay, we cannot really have any negative values. It is given in the question that x and y are actually non-negative integers, which means, let me write the condition here, xi, yi are actually greater than equals to 0. Okay, so these are all the possible values that we can get for xi and yi. If you see, apart from this value and this value, all these values are actually product of xi's and y's for different indexes. Okay, but even if they're product of different indexes, there's a general rule that whenever we are trying to find the product and we need to minimize the product, instead of having two average values, you should actually take one larger value and one smaller value. What I mean by that is, okay, what I mean by that is product of 2 and 2 is greater than product of 3 and 1 and 4 and 0. So basically 2 into 2 is greater than 3 times 1 and 4 times 0. If you take any random number, let's say if you had like 10, product of 5 plus 5 is the maximum product. Okay, if you take the product of 6 times 4 also, this is what, 25. 6 times 4 is 24. If you try to take for 3 times 7, it is actually 21. So the product keeps on decreasing. So in order to have the least product, you need to take one very large value and one very small value. Okay, so now, which means if you're trying to minimize y2, you have to maximize x3. Okay, or if you're trying to maximize y2, you have to minimize x3. In general, if we are trying to minimize x's for all these values, then we need to try to find the maximum values of these values. Okay, such that when we find this product, this turns out to be minimum possible. Okay, now let me write this pattern. What is this pattern if you see? So we had one A1. Okay, then we had what? X2, Y2. Then we had X3, Y3. Then we had what? X4, Y4. Then we had X5, Y5. And let's say we had only 5 values. Okay, then we have A of 5. Okay, now if you see, what are we actually doing? We have to find the product of these. Then we have to find the product of these. Then we have to find the product of these. Then these. Then these. Okay, and let's assume we were trying to minimize x's and maximize y's. Okay, now it could be that we were trying to minimize x's and maximize y's, okay, for the starting values, but after some time we thought it's better to take maximize x and minimize y. Basically, instead of doing this, okay, we might actually do, how do I explain this? Okay, like basically we could actually swap these values. Okay, so we were trying to minimize these, maximize these. So basically, maybe we can actually, if this is a1, we had x2, y2. For this part, it is same. Okay, but then after y2, we thought instead of trying to maximize x, we can actually minimize y. So like we can actually minimize y. So this is what, y3, x3. Okay, then again, let's say we have what, y4, x4, y5, x5, and a of 5. Now also if you try to do like this, okay, or let me like take it in an easier way. I think this is a little difficult to understand. Okay, so yeah, we know that we are trying to minimize x's and maximize y's. Okay, what if midway we thought that instead of maximizing x, maybe it's better to maximize y's now, minimize y's now, and maximize x. Okay, because we are given this pattern, we don't really know at what point we might to change the values. All we know is that if you're trying to minimize an x for a given value, we have to maximize y. Okay, but it is not sure that, okay, do we have to minimize x's for all the values or for all the y's? Okay, it might be that for some values we try to minimize x and for some other values we try to minimize y. Okay, so if that is the case, okay, what do we have to do? Right now we are multiplying a1 with x2, y2 with x3, y3 with x4, y4 with x5, and y5 with a5. If we actually reverse this, let's say at the very last point, we thought it is better to maximize x and minimize y. If we do that, okay, this is the maximum value. Okay, but since this is the maximum value, okay, and this is also a maximum value, okay, we have to multiply it with y5 now, because then only we'll actually get a smaller value. So we had x4 and then y4. Instead of multiplying this y5 with a5, we multiply this y5 with y4 because this y4 is large. So we have y5, x5 here, and then a5. Okay, so now this has to be multiplied, and then this has to be multiplied. Okay, so as we can see, we actually switched the values here. We had x5, y5, now we have y5, x5. It doesn't matter because in the end, all we wanted was x5 plus y5 should be equal to a of 5. Even here, y5 plus x5, we just have switched the values. x5 actually takes the value of y5, y5 actually takes the value of x5. Okay, and that's it. Okay, now how do we actually write this into a code? Because it might be, for now I showed for this very last product, it might be that any time in the course we can actually switch the values. Okay, it can be that instead of switching one time, we can actually switch multiple times. Okay, so how do we handle those cases? So basically, what I'm saying is, can I duplicate this? I don't know why am I actually able to copy this. Okay, I'll write it again actually. It might be that I had A1, then A2, y2. Okay, now instead of multiplying this with x3 only, I multiplied it with y3, and here x3. Now again the same thing, what, y4, x4, y5, x5, and then a5. Again these are multiplied. Okay, make sure, one more understanding, when I write y5 and x3 here, y3 and x3 here, it doesn't really mean that I'm actually going to multiply y2 with y3. I will be multiplying y2 with x3 only, but I will switch the values. So basically if I just remove this, I will swap the values at this point. So y3 will become x3 and x3 will become y3. Similarly, I could say that, okay, I'm actually getting a better answer when I try to swap this, and so on. So basically, we had a1 and we had a of n. Okay, then we had what? x2, y2, x3, y3, x4, y4, so on till x of n minus 1, y of n minus 1. And how are these actually multiplied? These are multiplied like this. So this is multiplied by this, this is multiplied by this, this is multiplied by this, and then this is multiplied by this. This is multiplied by this. Okay. Now it might be that we feel that we actually get a, so okay, how do we, the equation after this comes out to be a1 times x2 plus y2 times x3, y3 times x4, y4 times x of n minus 1, and y of n minus 1 times a of n. It might be that we feel that summation of this sequence is actually larger than the summation of when we switch these values. Okay, when you try to switch the values, this is y only, x, y. Okay, yeah. When you actually switch these two values, so when you switch these two values, your x of n minus 1 actually takes the value of y of n minus 1. You're not necessarily, the equation remains the same, but you take the, let's say this was 2, this was 3. Okay, you know that multiplying this 3, let's say this is 5, multiplying this 3 with this 5 will actually give you a larger result. So what you do, you swap this 3 and 2. So you make this 3, 2, you make this 2, 3, and you make this 3, 2. Now you know 2 times 5 is actually small. Okay, but how do we decide at what index we actually have to swap the values? The truth is we can't really decide on our own. We have to see for every possible case. And if you try to see for every possible case, you'll actually have so many combinations. And for that, you actually have to see, like, try to write a dynamic programming solution here. So how do you do that? Basically, let me just copy this, like drag this actually. Okay, so I had this. Okay, let's say I am done till this index. Okay, I am done till this index. Okay, and right now I say that, okay, now swap the values. Okay, so when I'm trying to write the DP, I need to see that, okay, what index I am at. Okay, this is one state. Okay, what is the other thing that I need? The other thing that I need is, was my previous value swapped or not? Because if I had already swapped x4, okay, if I had already swapped x4, instead of multiplying y4 with this value, I will actually have to multiply x4 with x of n minus 1. Okay, so I need that value. But I also need to ensure what is the next case that I'm actually coming on to. Am I going to swap the next value or not? Because one way of product is y4 times x of n minus 1. The other way could be y4 times y of n minus 1. So let's say this is turn. Okay. When turn is 0, I'm actually taking the normal case. When turn is 1, then swap. Swap the next values. Okay. So basically what I'm actually trying to say, my DP of index times what? Turn is actually, let's say this is my index. I'm actually at index 4. Okay. I need to have a previous value. Okay, or let's say this is next value. Okay, which will be given by my previous states. My previous states will tell, according to their swapping conditions, that what is the value that I have to multiply with this. Okay, so I will have some next value. This next right now is y4. This next will be multiplied by x of index plus 1. Okay, plus dp of index plus 1 times like turn. Like turn right now is 0, because if you see, we didn't really swap anything. We wrote x of index plus 1 only, but it might also be next times, instead of x I'll write y now, y times index plus 1 plus dp of index plus 1 times 1. Okay, why 1? Because now I have swapped these values. Okay, so I need to tell my next state that I'm actually coming with a swapped value and this is a different state. So whatever answer you are going to provide me will be different from whatever answer you will provide me. So these are two different states. This is state 0, this is state 1. When I don't swap the values and when I swap the values. Okay, so you need to have these two states. And this next is nothing but what previous value I got from all the previous multiplications, which I need to use for my next state. So this is my next value. Okay, let me go to the code and then try to explain this approach. It will become very much easier from that. Let me just read the chat. Okay, nice. I see now how DP came to the picture. Okay. Dharmesh says, how did you come to know the property you mentioned that multiple of middles is greater and multiple of extremes is smallest? This is actually, you learn that, I don't really know like how and when I learned this, but this is a very generic property. If you didn't know till now, maybe you know now and it will help you in the future. Saurabh says, I started last year doing CP and used to watch a lot of your streams after doing contest, and today if everything goes right, I will be expert. Really, really nice, Saurabh. Don't forget to tag me in the LinkedIn post. Nirmal says, got it. Okay, cool. Let me show the code. Okay, things will become very much clear when I show the code. Okay, so this is the code actually. Let me take a screenshot. Okay, cool. So I'll explain all this later. Okay, let's say we had some x's and y's. Okay, I'll explain this part later. Before that, let me explain the DP. Okay, so what are we doing? We are at a certain index. So what we had? We had a1, we had x2, y2, x3, y3, so on till let me write x4, y3, y3, x4, y4, so on till x of n minus 1, y of n minus 1, and a of n. Okay, let's say we are at one random index. Okay, we are multiplying like this. Okay, we are at this index. This is what index 3. So our index value is 3. What is our next? Our next is nothing but y3, which is the value from the previous states, which is going to be multiplied for all the coming values. Okay, now is my index equals to n? No, it is not equal to n. This condition is nothing but when my index is actually n, I need to take my next value, which is this value, and multiply it with a of n. So this is one terminating condition. The other terminating condition is if I have already reached this state before, just return the answer. Otherwise, what do we do? One way is multiply next with x of index. Multiply next with x of index. So multiply these values, y of 3 and x of 3. My next is y of 3 right now. And then find the answer. Find the answer for all the remaining values, which is solve index plus 1, y of index, and this is 0 here. Let me just rub this. Okay, this is 0 here. Okay, find for 0 because I am assuming that I am not turning any values. Okay, but what if I actually swap these values? I swapped for this index. If I'm swapping for the next index, then I'll say multiply next with y times index. Next is what? Y of 3. Multiply this y3 with y4. I will give this y4 value to x4 because multiply this. Now find the value of all the remaining values. Okay, so solve index plus 1. Solve for all the remaining values where index is index plus 1 and x of index now. Instead of giving y of index as the next value, I will give x of index now. Okay, because I have swapped the value, so my x has become y now. Okay, and then 1, saying that okay, I have made a turn now. Okay, that's it. Then you find the minimum of all both these values, and then you return the answer. That is the DP part. What is this part? Let me explain these conditions. Okay, so what did we have? We had 1x, 1y. We knew that xi plus yi is actually equals to a of I. Okay. We also knew that what? If a of I is greater than 2s, okay, as like I'll tell you like how this came from. I had xi minus s times yi minus s is greater than equals to 0. Now, if I try to keep this equation positive, I will say that my x and y both are actually greater than equal to s. And if both of these are greater than equal to s, then according to this condition, my ai is greater than 2s. If my ai is greater than 2s and I am trying to minimize x, okay, I have to minimize x, maximize y. Remember, if I have to minimize x, I know that x has to be greater than equal to s. So why not fix x to s only? I will say my x is s. Okay, if my x is s, okay, what will my y be? My y will say that okay, I can actually be ai minus xi, and what is xi? Xi is s, so a of I minus s. So what? Ai minus s. Now, what if my ai is actually lesser than 2s? What if my ai is lesser than 2s, but greater than s? Okay, again, I need to minimize my x, maximize my y. Okay, if my AI is actually lesser than 2s, okay, then if you see, if I make my x equals to s, then my yi will become less than x, less than s. Okay, that is why I cannot do this. But what I can do is I can actually reverse these values. Okay, I can say my y is s now, so my x will become ai minus s. But since ai minus s is actually lesser than s, x will be smaller. Okay, and then the very last condition, if ai is actually lesser than s, okay, then I can say my xi is 0. Okay, if my xi will be 0 and yi will be equal to a of I. And that's it. This is some condition that you have to do in order to minimize, make sure that your x is minimized and your y is maximized. And after that, you have to write this DP solution. Okay. Okay, cool. I hope everybody is clear with the approach for problem C. I'll just remove all my markings so that you can see the clear code. Okay, you can just go to my like code forces handle as well. It's Navan16013 and then see the what the code as well. Okay, pretty tricky problem. There were many things that you had to see into this. It's okay if you are not an expert and not able to solve this problem. It takes some practice, a lot of practice actually, to solve these kinds of problems. Even I took more than 1 hour since I'm out of practice now. Okay, all right. So Naitik says watching a stream equals to nostalgia. Thank you, Naitik. Khabo says, what is this drawing tool? This is the actually I'm using an iPad. Okay, nothing special, and like it's just using the pencil. That's it. No like different third-party tool I'm using. All right. I hope this is clear to everyone now. Problem C is definitely tricky. I won't say it's an easy problem. We had very less submissions as you can see. Okay, I wish I could explain D as well, but like even I don't know the solution yet. I'm still trying to the problem. I'm very close to the solution, but I don't know the complete solution yet. All right. If nobody has any other problems, maybe I can like end the stream. D is anti-DSU. What is anti-DSU? I don't really know what is anti-DSU. Like I know we have to use DS. No, I think we don't really need DSU. We can actually like just have a DFS. I was trying to solve it with DFS only. I didn't really use any DSU. All right, cycle and D. Yes, yes, something related to that only. Like there are many conditions in D. I'm stuck at some of the conditions that okay. Like I think I'm missing some conditions actually. Maybe like it's a very different approach and that's an easier one. But yeah. All right, so I think we are done with the first three problems. I hope everybody is clear with the first three problems now. If yes, do drop a comment and tell me that okay, you understand everything. Okay, if no, even then also give me a comment so that I maybe I can try to improve in the next stream. And yeah, that's pretty much it about the stream. Make sure to like the stream as well and subscribe to the channel as well. The next contest is on when? Let me see. The next contest is on 1st of Feb, which is Tuesday, and it's a Div 2 contest only. So it will be a generic contest. Let's have a stream on Tuesday as well. The contest will start on 8 p.m. and end at 10 p.m. only, 10:05 p.m. only. I will hopefully come live at 10:30 only and try to solve the first three or four problems. Okay. All right. So that's it. Thank you for watching. Do subscribe to the channel.